friends, I welcome you all to the course Marketing Research and Analysis. In this lecture, we will continue with the one that we had left in the last one. So, in the last class we were discussing about the n-way ANOVA, which is nothing but an extension of the one-way ANOVA, right. So, we discussed that the one-way ANOVA is used when there are multiple more than two levels or groups, and then the researcher has to find a way to measure the significance of the test through a single way instead of having multiple t tests. But what would you do if you are faced with 2 factors or 3 factors or 4 factors, right, and each factor having let us say certain number of labels n, let us say. So, in such a condition we use the n-way ANOVA, right, which is very useful. So, so we understood that in life there are many cases where there are 2 let us say things, let us say x1 and x2, let us say this is for example the type of car, and this is the x2 is let us say the type of house. Now, this 2 things will affect the status of a person, let us say status. Now, status can let us say looks like a categorical, we need to have a dependent variable which is continuous. So, you may take let us say is the status the type of car and the type of house affects does the income of a person, let us say income. So, income is my dependent variable which is a continuous variable income, and I am measuring it through 2 factors. Now, factor 1 is type of car where I have 3 types of cars A, B and C, and I may have 3 types of or 4 types of houses, let us say or 2 types of houses, let us say D, E, F and G. So, when I know there are 2 such cases coming up, earlier in one-way ANOVA I was looking at the effect of only x1, the type of car, that means A, B, C on the income, or the let us say type of house D, E, F, G on the income, but now we are considering 2 factors at the same time, right, and we want to see whether not only this x1 and x2 have a direct impact on the income, and but do they have a interaction effect. That means let us say the type of car let us say is this is a very high cost car, let us say very high technology, right, a high tech car, and the type of house it is a palatial, it is a very big palatial house. So, when I am seeing these 2 things, right, are they together have making a some other kind of impact. So, in such conditions when I would see it is called an interaction effect, right. Interaction effect is, that means when the value of one factor or one factor depends on the value of another, right, another factor. So, this condition is called an interaction, and during a factorial design we had earlier also learnt during factorial design we had learnt that interaction effect is one of the most important things that need to be learnt while doing a factorial design, and thus we do it through a n-way ANOVA. We will see how to do that. Okay. So, in the last lecture I had explained you the steps what to do. It is very simple, just remember there are 2-3 things you need to find out: the sum of square total, the sum of square between the groups, the sum of square within the groups, or which is called error also, right. So, these 3 things are there, but only thing is that here the between becomes little elongated or extended when you have 2 factors, let us say. So, suppose I have 2 factors now x1 and x2, so it will become sum of square between for x1, sum of square between for x2, then if there is an interaction effect, if see please do not expect that if I am having 2 factors that is bound to be an interaction effect. No, first logically think whether these 2 factors is there any effect, is there any possible logically is there any effect on each other, or if they are not connected at all, then there is no point in making an interaction effect. But generally we see in real life in marketing research and other psychological things that there is an interaction effect. So, in that case we find out the sum of square of x1 and x2 together, right. These three things together will be added up with the sum of square within to make the total, let us say, right. So, this is what we had said. Okay. So, this plus this. So, this is a condition where a experimental data comprising of a given group of boys and girls of different age groups and their test scores on a maths test, that means, has been checked. We want to check whether gender and age group or both gender and age group have an impact on the test scores, and we want to test it at a 5% level of significance or 95% confidence level, right. Now, how do we proceed? First, let us see. First, we have to build the hypothesis. What is the hypothesis? Now, I have made it very simpler, for example, for you. Now, first we will see that the overall model should be significant. That means, if I am taking two factors and there is a dependent variable with two independent variables of different levels, I am saying this overall model should be significant. My null hypothesis is that, and alternative is it is not significant. Then next is I am saying both gender and age group will have no significant effect on students score. That means, here I have taken the interaction effect, I am taken the interaction effect, right. Similarly, I am saying gender and age group will have significant effect on the student score, right. Third, now we know that first you have to check your overall model, then you have to check your interaction effect, and if your interaction effect is not significant, then only you should check the main effect. So, now suppose it is insignificant, the interaction effect, then we are going for the main effect. What is it saying? Gender will have no significant effect on student score, gender will have a significant effect on the student score. Similarly, age group also will have no significant effect and age group will have. So, now these are the these two are the basically we are looking at the main effects. Okay. Okay. Now, let us proceed. Now, this is the gender. So, there are two groups, one boy and one girl, right. So, boys and girls, so male female, right, and age group which has been divided into 10, 11, 12. So, there are three age groups, children or students of 10, age group of 10, 11 and 12. The scores are given to you. So, there is a boy 10 years of age, he has scored 4, another boy 10 years 6, age 6, score 6, another boy 10 age score he has scored 8. Remember, all these boys and girls I could have written 1, 2, 3, 4, 5, 6, I should have in fact. So, because to avoid confusion for many people, because remember that they are not repeated, they are always different, right. Similarly, this is also 1, 2, 3, 4, 5, we do not repeat, we are not repeating here, right. So, this is all the scores you have got, right. So, now what is the independent variable? Gender. How many levels? 2, boy, girl, right. So, what is the second independent variable? Age. How many levels? 3, 10, 11 and 12, right. What is my dependent variable? Test score, right. So, this factorial design is a 2 cross 3, 2 cross 3, right, with 6 measurement cells, right. So, how it would look like this, right. So, age group you see 10, 11, 12, gender boys and girls. Now, when I am taking this total cells you see, so boys in the age group of 10 were 3, boys in the age group of 11 were 3, boys in the age group of 12 were 3. Similarly, girls also 3, 3, 3. So, how many is the total? If you say the total n is equal to how much? 3 plus 3 6 plus 3 9 plus 3 12 plus 3 15 plus 3 18. So, this is total is 18. Okay. Now this is, let us find out the first the mean, the average or the mean. So, 10 years the average for the boys in the 10-year age category is how much? 4, 6 and 8, 4, 6 and 8. So, how much it is? 6. Second for 11 it is 6 plus 6 12 plus 9 21 7, 39 22 plus 8 30. So, 10, right. So, similarly for the girls, so the 10-year aged girls the average mean score was 7, 8 4 12 9 21 by 3 7. So, this is 10 and this is 14. Okay. Now, let us write the mean table at one go. So, how does it look? So, boys girls 10 11 12. So, just imagine now this much only for at the moment. So, boys 10 years 6, 11 years 7, 12 years 10, girls 10 years 7, 11 years 10, 12 years 14. Okay. Now, find the mean of the, like you are doing in the ANOVA, similarly find the mean for the rows and the columns. So, what is the column total here? 7 plus 6 13 divided by 2 6.5, this is 8.5, this is how much 24 divided by 2 12. Okay. What is the column average? Now, the column average is 6 plus 7 13 plus 23 divided by 3, right. So, 23 divided by 3 is somewhere 3 7 is 21 to 7.7. Okay. Similarly, this is 10.3. Now, this finally after this you find the grand mean. So, this is the individual means, the column means and the row means, and column means and the row means, and now the grand mean. The grand mean is how much? So, 6.5 plus 8.5 is how much? 15 plus 12, 27 divided by 3. So, 9. So, now we have got the values, right. From here we will go to measure the sum of square, right. Now, what is it? The first it says we want to measure the sum of square total. So, what is the sum of square total? I had explained earlier, sum of square of the first factor, which is gender, plus sum of square of the second factor, which is the age group, plus sum of the square of both the factors. Let us take this one first, sum of the square of gender, age group plus both the factors, okay, age and gender. Okay. Then sum of square of the error. So, these 4 things together will be the sum of square of total. Okay. Now, let us do it one by one. Sum of square for the first factor, gender. Now, we will compare the boys and girls average with the total grand mean. So, here you see the boys case, the score, this is the score 4 6 8 6 6 9 8 9 13, right. Now, what is the boys average? 7.7. What is the grand mean? Now, the grand mean is 7.7 minus so the sum of square is 7.7 minus 9, that means the mean of the boys at the age group of, let us say the overall, let us go back 7 point, let me show you here. So, what is this? The boys, right. So, the mean of the boys or the average of the boys, right, is how much? 7.7. So, now what we are doing is 7.7 minus 9, 9 is my grand mean square. So, the same thing happens for all, right. So, I am getting a sum of square of how much? 15.2, right. Now, for girls, what is the value? Let us check, 10.3, right. So, girls is 10.3. So, average is 10.3. So, the girls average minus the grand mean. So, the average score of the girls minus the grand mean, the square of it. So, we are doing the between the groups now, right. So, between the genders, that means. So, this is giving us this much 1.69 and this total is 15.2 again, right. So, total sum of squares of the first factor is how much? 15.2 this one plus 15.2 this one is equal to how much? 30.4. Okay. Now, coming to the next for the age group. So, we will calculate the sum of square for the second factor. Now, let us go back to that earlier table. What is it? Age group 10 is 6.5, 8.5 and 12 is 12. Okay. So, I take the first one. So, 6.5 minus 9, the grand mean square. So, this is for the first 3, then the second, the 6, 8.5, 8.5 and 8.5, right. And then the third group, which is 12 year age group, right, it is 12, 12, 12 minus 9 square. So, what we have done the age group, we have taken the scores, right, and we have the means, that means this 6.5, 8.5, 12 and we have divided from the grand mean, okay, and we have found out the square. So, this is 46.5. Similarly, you do it for the girls. How much is the score? 6.5, 8.5, 12. Now, for the girls, let us go back. So, for this is the girls, right. So, 6.5, 8.5, 12, one more. So, when we are dividing, you will see that this score is again 46.5. So, now for the boys you see, so we have there are 3 age groups. So, average is 10, the mean is 6.5, for 11 it is 8.5, for 12 it is 12, right, grand mean is 9. So, now we will take it and we will divide it, subtract it. So, 6.5 minus 9 the grand mean square, and we are finding it, right. Similarly, we are finding it across the girls also, right. So, the total is 46.5 here, 46.5 here. So, total sum of squares for the second factor is how much? 93 for both boys and girls together. Now, after this we will find out the sum of square the within, for example. Now, within means the error term, right. Now, we will compare the average test score values of each group age group with the test scores obtained for the both boys and girls. So, average test scores of 10 years is 6, average test scores of 11 is 7, and test scores of 12 is 10. Now, you can see this here average test scores. So, 10, 11 and 12, right. 10 years is 6, 11 7, 12 is 10, right. Okay. Now, let us do this. So, what is it saying? When you calculate the within the variance, that means within the group, what you have to do is you have to subtract the observed value minus the mean of that particular column, right. So, in this case the column score the mean was 6 for the 10-year for this 10-year-old boys, right, and 11-year-old was 7. So, let us take it and finally 10. So, the scores are given to you, and what is the average test score is given to you, and the boys test score is now to be calculated, right. So, first boy got 4, then minus 6 square. So, 6 minus 6 square, this is, I hope you are understanding, this is the observed value minus the column mean, okay. So, observed value is 4, column mean was 6, observed value is 6 minus column mean 6, observed value 8, column is 6. Second case for 11-year age, 6, column was 7, observed 6, 7. So, it goes on, right. So, when you do this, so the square when I take the square of it, 4 minus 6 is minus 2, square is 4, right. So, this sum of square is coming 28. Now, let us find it for girls similarly. So, girls it is 4 the observed value minus 7 is my mean, 8 minus 7, 9 minus 7, 7 minus 10, right, 10 minus 10, 13 minus 10, you have to just refer to the table, original table again and again, right, and 12 minus 14 goes on. So, this deviation score, so 2 square is 3 square, right, is 9, 1 square 1, so it goes on. So, this is total 40. So, what is my total sum of square within? Now, total sum of square is within is 40 plus 28 is equal to 68, right. Now, you have to do one more thing, you have to calculate either the interaction or the total, right. So, let us do the sum of square total, now we are calculating. Now, what is the sum of square total? How do you do that? Simple, each observed value minus the grand mean the square of it, right. Now, each observed value was 4 for example, minus the grand mean is 9 square. So, take all the values of both the boys and the girls together, right. So, if you take the sum of square of total irrespective of boy, girl, anything, so it is coming 200, right. So, this is the total, right. Now, interaction effect you can just subtract the rest from the total and find out the interaction effect. So, what it is saying, sum of square of both factors is equal to sum of squares of total minus the sum of square of the first factor gender, sum of square of the second factor age group minus the sum of square within, right. So, if I sum of square within, right, sum of square total yes, we are subtracting, this is the interaction effect, interaction, right. So, interaction. So, interaction is equal to total minus the rest, this rest, right. So, that is equal to 200 minus 30.4, let us see 200 minus 40 minus this is 93 and this is 30.4, let us see. So, let us see. So, 30.4 minus 93 minus 68 because 40 plus 28 was 68. So, this is giving us the sum of square of the both the factors of the interaction x1 x2, right. This is x1 x2 is equal to how much 8.6. Okay. Now, the degree of freedom for the first factor gender is how much? Number of rows or the levels minus 1. So, how many are there? 2 levels are there, boys and girls. So, minus 1 is 1. For the age group how much? 3 minus 1 2, right. degree of freedom for the sum of squares within is equal to how much? The number of observations for each group for both boys and girls minus 1. Now, you see this, in this case there are 3 groups of boys and 3 groups of girls. So, n minus 1 is equal to how much? 3 minus 1, that is equal to 2. So, because there are 3 elements in each group, since there are 3 age group for both boys and girls, so how much it becomes? Now, this 2, right, into 3 into 2. Now, that means what? Or you can simply do it like this, the how many there are, let us see this. Now, there are 3 here, so 3 minus 1 from here, 3 minus 1 here, 3 minus 1 here. So, you do it 3 minus 1 here, 3 minus 1 here, 3 minus 1 here. So, if you add 2 plus 2 plus 2 plus 2 plus 2 plus 2 is equal to 12, right. So, the degree of freedom for the interaction is equal to 12, right, is equal to 12. Degree of freedom for the sum of square of both the factors is equal to how much? The degree of freedom for the first factor gender into the degree of freedom of the second factor age, because this is an interaction effect multiplication. So, how much? 2 minus 1 into 3 minus 1, so 2. So, the degree of freedom for the sum of squares total is how much? Now, n is 18 which you had minus 1, right. So, sum of square of total is equal to 17 in this case. Now we have to find out the F ratio. F ratio for the row is equal to mean sum of squares row divided by the mean sum of squares error. This is how the formula is given. F is equal to ms between divided by degree of freedom between for by ms within divided by df within. Okay. So, the ratio, the F ratio mean of sum squares row by mean of squares error, right. Similarly, mean sum of squares of column, because there are 2 rows and columns are different, 2 different factors, that is why this is being done. And for the interaction, mean sum of squares of both the factors divided by mean sum of squares the error term, right. Now, the error is constant, see, in all the 3, right. Only thing that is changing is here the row first value, the column value, this is the gender one, this is the age one, and this is the interaction one, right. Now, so let us make this table. So, first factor, what was the sum of square? 30.4. What was the degree of freedom? 1. What was the second factor? Age. How many? What was the sum of square? 93. What is the degree of freedom? 3 minus 1, 2. What is the sum of square of both the factors? The interaction? Now 8.6. So, total minus we did it. And what is the degree of freedom? 2, right. Okay. And then we had sum of squares within. What is the total? The within is 68. What is the degree of freedom? 12, right. Each was you were minusing 1 from each, right, and total is now 217, right. So, this gives us the total mean square. So, this is you can find out the ms square, right, the mean sum of square. Now, this value when you do have it, so this is 30.4 divided by 1, 93 divided by 2. So, this is all you get. So, finally, you get the F ratio. Now, F ratio for the first factor is how much? 5.36, second 8.2, third is 0.76. Now, from here we will find out, we will go step by step. So, we have calculated all the values. So, overall effect of F at 5 and 12, what is this 5? 5 is the numerator, because there were 6 groups, if you remember 6 groups, right. So, 6 minus 1, and 12 is 18 minus 1 from each. So, 18 minus 6, so that is by 12. P is at a less than 0.05, 5% level. The critical value from the F table is 3.11, right. I have that F table, I think, okay, it is not here. So, is 3.11, and the calculated value we have got is how much? Check here, 4.65. So, we have not, okay, we have calculated here, right. So, since how do you calculate? You see the formula is given to you. So, F is equal to the final F ratio is overall, for the overall model is SS sum of square x1 plus sum of square x2 plus sum of square x1 x2 the interaction divided by the degree of freedom upon again the sum of square error divided by the degree of freedom d, right. So, this gives us how much? SS x1 was 30.4 plus 93 plus 8.6 divided by 5, again divided whole is by the error, which is 68 divided by 12. So, this gives us say 4.65. So, this is what we have said. Since this calculated value is greater than the table value, we reject the null hypothesis. So, what is my null hypothesis? That the overall model is significant, is there is no impact, or there is it is not significant, right. So, now the overall model is found to be significant, it is the null hypothesis is rejected, right. So, and how do you calculate the degree of freedom? It is given to you C1 into C2 minus 1. So, you without this also you can do, we have already, I have already told you how to do. So, this is done, right. So, 6 groups 3 into 2 minus 1, similarly here. Now, the interaction effect of gender and age group is how much at degrees of freedom is gender 2, age group is you have 12, gender into age group, the total is 2 into 12. Why? Just if you see 2 was your number of, yes 2, and age group, so it is coming 12. So, 12 is because of this we have the overall, this is the one we are talking about, degree of freedom denominator, right. The critical value of F table is 3.89. So, now the interaction effect you see at 2 and 12 degrees of freedom and level of significance 0.05, right, is the from the F table the value is 3.89 and calculated is 0.76. You do you remember where we calculated 0.76 here, right. So, 2 and then we had 4.3, 4.3 is this 2 is divided by 4.3, this one, this value divided by 5.67, right. So, when you divide this 5.67 also, I hope you remember when we got this 5.67, this 5.67 we got it from the, yes, this value, right. So, sum of square within error. So, when you do this, so we fail is, so since the calculated value is smaller than the critical value is how much 3.89, calculated value 7.76. So, we fail to reject the null hypothesis, thus we cannot say, that means the interaction effect is found to be insignificant, not significant. Thus, we move to the next step, that is measure the main effects, right. Now, coming to the main effects, first we will calculate for gender only. So, 1 and 12, so 1 and 12 is the two numerator and denominator degrees of freedom. The critical value from F table is 4.75 and the calculated value is 5.36, right. Now, let us again go back, so 5.36, right, and you have 4.75 I think. So, calculated value is table value is 4.75. So, the null hypothesis is rejected. That means what? The null hypothesis rejected means that it says that the gender has a significant effect on the scores obtained by the students, right. Second, we will check for age group, the second main effect. So, at 2, 12, 2 is because 3 levels were there. So, 3 minus 1 and 12 is the denominator. So, the critical value is again 3.89 from the F table we will see, and calculated value is 8.2, right. So, if you check back the table, since the calculated value is again greater than the critical value, the null hypothesis is again rejected. That means what? Age group also plays a vital role in the performance of the students, okay. So, what is the interpretation? The interpretation is that gender will have significant effect on students score, age group will have significant effect on students score, both gender and age group will have no significant effect on the student score. What I will do is, I will try to instead of going for another problem, I will try to show you how to do this in the SPSS. For example, let me take a problem. Now, I will show you through this problem how to go for a two-way ANOVA test. Now, this is a case where there are two things. One is the day, on which day the newspaper is coming, right, and this is the type of paper, right. The type of paper could be a daily magazine, a daily newspaper, economic, weekly or something, some kind of there are 3 types of papers, 5 days in a week, and it has been tried to see whether the number hits, right, the advertisement hits, right, is it related to the day, to the day and the type of paper, right. So, that means what it is saying simply, is the advertisement, the hit or the popularity of the advertisement given in the paper, does it depend on which day this paper is coming and in which type of paper it is, the advertisement is being shown. So, to do this you have two categorical variables. So, and there are two factors, two independent, this is one independent variable, this is another independent variable, and this is my dependent variable. So, to do this I will do a two-way ANOVA. Now, how to do this? Now, first go to analyze. Now, you cannot do a through a compare means you cannot do it, because it is only allows you for a one-way ANOVA, and it does not allow you for a interaction effect or for two factors, more than one factor, right. So, we use a general linear model. This is used when you are doing a two-way ANOVA or n-way ANOVA, right. So, what you do is univariate, right. So, why univariate? Because there is only one dependent variable we have, okay. So, what is the dependent variable I am taking is now my hits. What is my independent variables? Independent variables are called my factors, fixed factors, right. So, I am taking, had I had some covariate, that means some continuous variable here, I would have put it in the covariate. Now, let us check. You want to check the plots, you can check. So, you want to check add, you want to see the effect of paper, you can check. Now, I can also see, right, the effect of both day and paper together. So, that is what I am trying to see, an interaction effect, okay. Continuous. You can see the post hoc effect. Now, what is the post hoc effect? Post hoc effect tells you, suppose you have found out yes, there is a significant difference among the 5 papers, but or the 5 days, but then can you say which day has got the highest impact or which day has the lowest impact? No. So, to understand such kind of things, where we want to measure between the days or between the papers, type of paper, we will use a post hoc test, right. So, generally we use the Tukey's test or the LSD, or if it is a small sample size, we use a Bonferroni, okay. Okay. Now, I am going for some options. Now, options are, for example, I want to check for the overall model, the means for the day, paper and these 3, and I want to compare the main effects, right. I want to go through two different things. One is the descriptive statistics I want to see, and I want to see the homogeneity test. Now, homogeneity test, I had in the beginning of the class I had said that it has to be very important that the homogeneity of variance between the groups is not significant. That means, the null hypothesis which says that there is no difference should be accepted in case of a homogeneity of variance test. That means, the researcher has to say that the groups, there is no difference in the variance between the different groups. That is what homogeneity of variance or the Levin's test does, okay. And this is a very popular this is an important assumption, okay. Now, let us run this. So, let us go to the output table. So, if you go to the output, what it says, there are 5 days, 12 each respondents we have taken, 3 papers. So, the same 60 is divided by into 3, right, 20, 20, 20. Now, let us look at the mean. Now, day 1, let us say day 1 paper 1, day 1 paper 2. Now, look at the mean. So, day 1 paper 1, the mean is 8.25, the hit the popularity, standard deviation is given to you. For day 1 paper 2 11.5, day 1 paper 3 is only 4.5, that means the advertisement hit is very low here, and the average overall average is 8.8083. Similarly, for second day paper 1 10.5, second day paper 2 8.75, second day third paper 6.5, and goes on. So, you can check for all, right. So, the overall total is also given to you for paper 1, paper 2, paper 3, right. Now, as I had said, first of all we have to check for the Levin's test or the equality of variance. Now, since it is above 0.05, that means we can easily say that this you cannot reject the null hypothesis, the null hypothesis is to be accepted, right. So, and this is what we wanted. So, what it says, the test the null hypothesis that the error variance is equal across groups, which is found to be true, okay. Now, coming to the test of between subjects effects, right. So, what is it? Now, the overall model we have seen that is significant. Now, intercept leave it. Now, coming to the day, is the day in which the advertisement is given and that results in its popularity or not, is that significant or not significant? Now, we have seen yes, it is significant, right. So, the F ratio is 20 and it is significant. Does the type of paper is it significant? Yes, it is significant. Is the interaction effect significant? Yes, it is significant. So, luckily this time we have got all the 3 significant. In many cases I have seen you may get only one of them significant, or only the interaction effect significant and none of the main effects significant, or only one of the main effects and the interaction effect significant. Rarely we get all the 3. Generally I have not seen many of the cases, right. Then we can check it individually, right. Now coming to the post hoc test. Now this is important. Now here what you can do is, now you can compare. You have now seen whether the papers are okay significant, the day is significant, but let us make a comparison between the days. Now first day and second day, is there a significant difference between first and second day? Let us look at the difference and the significance. No, it is not significant. First and third day, is it significant? No. First and fourth day, yes, it is significant. First and fifth day, yes, it is significant. Similarly, second day and the let us say the third day, right, we have not compared. So, not significant. Second and fourth, yes, second and fifth again, yes. So, when you check this, it helps to tell you whether there is a significant effect or the significant difference between the different days on which the advertisement is given, right. So, by doing this, right, so it, see, this is what we were doing. So, this is the right. So, it is sorry, I showed you you should see this table, sorry, the 2 keys HSD, this is the post hoc test, right. So, you can see the 5th day one, all are significant mostly, and what is not significant, third day and second day, no significant difference, and first day and the third day, no, obviously not, right. So, this is what paper also, for paper also you can see, now it is here for the day we did it, for paper you can compare among the papers 1 and 2, is it significant? No. 1 and 3, yes, significant. 2 and 3, yes, significant. So, this helps to tell you, and you can even check the profile plots also, that is there for you. Now, how it looks like. So, this gives a very clear picture of how to do a two-way ANOVA test, right. Well, what we will do is we will continue this maybe into the next class with some other kind of tests which are there. So, thank you for the day. I hope you understood what is two-way ANOVA, and kindly when you follow the my class, try to stop it in between and take a pause and think what I am saying, and in case you have doubts you can always fall back on me, but if you, I am sure if you listen to it and give a patient hearing for once or 2 times, you will be completely clear on what is N-way ANOVA and how to do it, right. Thank you very much.